guess we'll start off. If you guys have any questions, you can go to that URL and then post a question, and we'll be able to see it over here. And then at that end, we'll answer any questions. You can follow up with other questions if you haven't. You wanted to ask the same question?
That link will stay at the top throughout this slide. We kind of did this because we have a lot of content to get through, and we might end up answering your question later on.
So we're going to start off. I'm Andrew Shimon.
Shane Young.
And I'm Mike Blatt. You can find our emails at the end of the slide if anybody wants to reach out and ask additional questions. Otherwise, I'm Mike at mcollette.com, James at C1 at my mail, and Patience31 at Gmail.
So I guess our project is Temp Helen. Does anyone here have a Nest?
Or Ecobee or
Any smart
Honeywell.
Yeah,
One of them.
So they collect a lot of data, but very few of them will let you actually view the data that they collect on you. So our goal for this project was to kind of do some reporting on that, and so you can lower the monthly energy bill in your house. So what we did is we built a web app that talks to a Raspberry Pi or your smart device if you have a smart temperature. And then based on that, we can graph kind of temperatures throughout the days, and we can kind of say if it's 70 degrees in your house and an hour later it's down to 60, you probably have problems. It's the winter, and you can make your house more energy efficient that way. So I guess we can jump right into kind of the project.
So first off, Shane's going to give you guys a quick demo of our actual website, and then we'll explain how everything works after that, so you kind of know where we're coming from here.
All right. Here is our landing screen when you go to temphelmet.com. We just have some information on how it works. Pricing, FAQs. Go to the top and you can log in. And it's signing in with Google. It takes a little while for it to spin up. It's actually going to, it's actually going to Azure services, so we have to wait for all that to spin up. What we have over here is our live graph. These are actually 3 different Raspberry Pis that are at all of our houses. So if we move from one to another, as you can see, the bedroom one, or Andrew's, that he's holding, is not reporting any temperatures, which is why we have this warning at the top. And if you go over to the live data, this is actually minute by minute. This is in 15-minute increments. We also have alerts so that if you have a 5-degree temperature difference within your 15 minutes, it will also have a warning at the top. We have our notifications. And then we can also change the zip code. So if we enter 123, go back to our dashboard, and that is the zip code for New York. This is coming from Weather Underground. And that is our background.
Another cool thing about this is that the data for the graphs are all cached. So once you have it loaded up and you switch back and forth between the rooms, it doesn't have to go out and load all that data into it.
Thank you, Shane. So with all this data, you're probably wondering how actually all this stuff is working together in the background. So this is a wonderful little map we created to help you guys out. Okay, bye. I'm just kidding. So what we're doing right here is first off, we're using a whole bunch of Azure services. I don't know how many people have used a lot of Azure services, but we tried to basically include as many as we can so we can learn a lot more. Starting out, Andrew shows you kind of the Raspberry Pis. So up here, top right corner, you see a bunch of Raspberry Pis. They're all running Windows IoT Core. On there, We wrote a program, loaded it up on there. It's like literally like running a Windows machine on your Raspberry Pi. And all those devices are talking to Azure IoT Hub. And from IoT Hub, we're basically taking that data and sending it over to Azure Stream Analytics. And what this is doing is gathering the data and sending it wherever we need to send it. So for instance, the Raspberry Pis, we're collecting data every single minute, but we're not storing it every single minute. What we're doing is every 15 minutes, we're sending data to an Azure Table Storage, which is a NoSQL service they offer. And this storage is like this, you saw on the lower left of the website. It was just, it's basically on the website, you can see the last, was it 3 days? I think the last 3 days right now, which is configurable. And then the minute-by-minute database, or minute-by-minute data, they actually have going up to an Azure function. These are their serverless functions. So that it's just a serverless compute option. It's just one function, and all it does is take data, send it somewhere. Take data, send it somewhere. So that data is going to an Azure Redis cache. We're using it right now as a key value store. And since it's so efficient and so fast, it's very handy for this minute-by-minute data that we're storing the last 15 minutes, I think. Is that right? Yeah, the last, the last like 3 hours I think I have on there. Yeah, so we're storing literally data just for the last couple hours. Once that hour time has spanned, it just disappears. So right now, every single key in the database is only a few kilobytes large, so we can support many devices. Then the other option we have, we mentioned like the Ecobee, the Nest, and then a Honeywell device. These are your smart thermostats at home. These actually go to a separate API. So we wrote an application in Go. It's a language that I'm a big proponent of. I love Go. And what we did, since we can't really run a Go app very well without paying a whole bunch of money to Azure, we ran it in a container. So here we're using Azure Container Service, which also gives us the option of using Kubernetes, which is an orchestration service, which means it's telling a VM to load up here, have this container, telling another one to load up there with that container, and telling everything where to go. So that's running our Go application, which is an API to open a streaming connection to all the thermostats. We did this because they need to be kind of stateful, because at least for an example, Nest uses I think it's the JSON Event Hub protocol. So it's just a streaming connection that continually streams an event. And we needed that open connection. We didn't want it to be stateless, like for an Azure function, because that connection needs to stay open. To manage all that, the second part of that Go application, so technically it's the second application, it's like a job management service. So anytime you have a new device, basically it gets pushed to a database, and then that gets consumed by the second application, which decides to open a connection, to close a connection, etc. And all that does is just goes into Azure Data Storage in the 15-minute increment that we did for the Stream Analytics with the Raspberry Pis as well. Below that, we also have just our standard app service. Our website is run on Azure App Service using Identity for a login system, and then all the users on that application are just stored in a SQL Server database. So it's kind of a lot. At this point, nobody asked us any questions. So does anybody have any questions about anything in here? Yeah.
What's the Redis cache?
Redis cache is an in-memory database that basically stores objects. You can store key value pairs, you can store text, you can store blobs of all sorts of things. We're using it to store just basically blobs of JSON. As an example, if you're curious, so this is just a GUI for a Redis management tool. In here, we're storing it by namespace of a device ID with a key of MPC Pi 3, so this is one of our Pis. And then here we're just storing a sorted list, and then you can see the data right here. So that's all we're using Redis for. It was just a fast, efficient way to deal with that.
So what was the most difficult part of the process?
Getting it all to work together properly. Because I mean, we're setting up a service, we're making sure that service can connect to another service. Then our website we're using the new ES7's and JavaScript's async and await to do all like the JSON fetches and stuff that the API puts out. So that's really cool.
How many records?
30,000 the last I checked. 30,000 in our NoSQL database. That's just a period of, I don't know, a couple months, yeah. That actually so far that's 30,000 records. I mean, it's not a lot, but I'm up to like 12 cents on Azure so far, so that hasn't been an issue. Anybody else?
I put questions in.
Yeah.
I put questions in.
Did you really?
I did.
All right, well, Brian has some questions, everybody. Would you guys like to see his questions? So, I don't know if you guys have used Google Slides before, but yeah,
Pretty cool.
it's really cool. And you guys can actually like upvote and downvote questions. It's really cool. What control is used for the dashboard charting?
That is chart.js.
So JavaScript here?
Both of these.
Yeah, so if you hover over icons, you can see a bunch of cool details that are in there too, temperature, humidity, and then the other one on the right actually shows just more detailed information because it's the minute one.
It's simple to use,
Yes.
No, it was fun to set up actually. There's a lot of configuration that goes into setting it up properly.
Oh, so it isn't?
No, it wasn't. I was being sarcastic.
Okay.
Yeah, it's
Well, after you know where the controls are and how to actually access them, it does get a lot easier than using, say, Sparkline.
Yeah.
oh yeah.
But initially, like learning it, it's completely different than what we used to. There was a learning curve.
I think
It's
that
nice.
took all of us what, a couple of weeks just to figure out the actual configuration.
I was
How we
just
want it to
happy
look.
to get a chart on there
Yeah.
first.
Yeah, that was the
Without
first
anything
step.
on it.
Yeah, even just like getting it to set up into these like certain period increments. Yeah, that was fun.
So if you had to do the project all over again, what would you do different? Or would you do one thing you change? You can't say team members.
Can you, let's see, go back to the desktop real quick. So, if I were to change something, it would be, oh man, honestly, I would probably use more Azure services. It was just fun. I don't know. Is there anything you guys would change?
Well, if you're trying to keep costs down, I would actually use less Azure services or different ones. Because it will skyrocket the battery cap.
Yeah. Greg gave us a great point of Redis being ridiculously expensive, so we're just using for fun.
Do you feel you might have been able to accomplish the same thing using less services?
Oh yeah. This was a learning experience. We just tried to throw as many learning opportunities we could into this application catch.
Very impressive.
We're also using Power BI before the API was up to just view all the stuff.
Because Mike got sick of us saying, hey, what's the temperature in my house?
Yeah.
And we had continuous integration set up, so when we're working on a team, anytime you checked in, it just published right to the website. So that was nice. And if your code didn't compile, it wouldn't publish. So.
Which is frustrating.
A second question we have by Brian. What are the Azure costs for the containers? The way we did it, using VMs, it was way cheaper than using the Linux app service, which is the only app service that supports containers. App service on Linux, I think I want to say is in the high $30, low $40 a month range. VMs, we're running like one free VM, and then I think our other VMs are like maybe $10 a month or $8 a month or something. I don't remember off the top of my head, but we did it that way because it was way cheaper. And then we could also use Kubernetes and container service, Kubernetes. I don't know if you can use Kubernetes with an app service off the top of my head. We can try it.
Any other questions?
Good work.